This is a 3DR Iris. This is Iris Plus. Very good stable product. It's an open source flight controller. So it allows a lot of manipulating of everything from sensors. You can add additional sensors to it. It's just very good gear too. Alias.
And is this the S800?
That's the S800. This is our professional bird. It's got a Zimuse stabilized gimbal with a Sony NEX. That's the 7. 2-operator platform. I do have a camera. What I like to set my systems up on is I'll put the payload operator on a separate system and the drone operator or the UAS operator on his own transmitter. So with my transmitter, I can view on my screen, I can view a nav cam, which is this little camera right here. That always gives me an orientation view of straightforward. So I can view on the nav cam and know exactly where I'm facing and which direction I'm going. Then I can switch. I have a selectable switch based on the flight control. I can select to see what my my payload operator is viewing. So I can see either or. So I know if I need to, if he's getting whatever his subject is he's shooting, I can reposition the platform to better assist him in doing that shot, or a moving target. Moving target is good to have either forward or backwards moving, right? So with orientation based on his view, I can position the system to where if he needs me to follow that moving target, I can set myself up for that. This is it's got retracts, like I said, just like the one you saw demoed. The retracts clear the field of view, 360. You can turn that thing all the way around, completely control the camera. From shutter, from remote shutter, video, he can do it all. It's a little bigger. You can handle a lot more wind. It's a heavy lifter. It's a noise maker. You can definitely hear it taking off. It's a good, reliable system. And of course, these are the monitors. This is a trainer we use for FPV flying, first-person view. Just a simple camera with a video downlink, 5.8. It's orientation, so it doesn't. Whichever way the camera or the drone actually tilts, the camera tilts with it, so you can actually see orientation. It's easier making turns, understanding when you fly around a corner and turn how the system pitches, and seeing its relation with the live video feed. So it's a good trainer. Whereas if you train with this with FPV, the camera stays put. The camera floats in the sky. So to get a feel of how the system is turning and banking, you don't get that with the stabilized gimbal controls. And these are just other systems. This was a custom bird I built. This is the older system, a Y6 that was built several years ago, probably 3 years ago. One of the first NASA systems in it. And as you can see, you take out the guts of it. Back when the first NASA came out, we had issues with RF and radio frequency interference. So sealing it up, shielding it. That was the way I found actually got more reliable. It's kind of monstrous looking, but I added a negative ground to it to jack up the ions, but it worked. It worked real good. So these are videos. Like I said, I'm not going to show the videos. You can pull them up. A perfect video: guy flying in his backyard, and the drone does a nice little fly off. Okay. If you don't understand, like I said, the components, that when you launch this thing from near buildings, if you don't monitor the LED sequence that tells you the startup process, if you don't know what kind of satellite lock you get, and because of reflection, if you launch in areas where you're between buildings, between structures, you can get a wrong reading that will send this thing doing a crazy place, a flyaway. So, and those are examples. Another example is a boat, a moving object. Okay, guy launched it from a boat, and he didn't allow the system to rest, to stabilize, to get its startup process, completed. So when he did lift, it flew out. It flew just fine at first, and then you start seeing it do this whole whirlpool thing. Whirlpool, the toilet bowl effect, is all issues with GPS. GPS has a problem. It's not locking. It's getting reflection. It's not, it's not doing its right thing. So they're all perfect crashes. Of course, everybody's probably looking for satellites. Well, buildings, concrete, when you operate within structures, okay, you get reflection. You get reflection of GPS signals off of buildings, right? So with that, you could have a ghost GPS signal. Your system could lock to GPS, but it could be a ghost signal. You've heard about fly-offs and other issues that happen when these lower cost GPS signals get a lock. Sometimes that lock isn't that position it's in. Okay, so when you activate fail-safes and other modes using GPS to hold its position,